Okay, we have the second keynote speaker. I'm very pleased to introduce Professor Tamaka Ura. Professor Tamaka Ura is a director and a professor of Underwater Technology Research Center at the Institute of Industrial Science of the University of Tokyo, and the director of the Tokyo University Ocean Alliance since its establishment in 2007. He is one of the top leaders of development of autonomous underwater vehicle in the world. He has developed not only autonomous underwater vehicles, but also various related application technologies, including navigation methods and new sensing methods using chemical sensor, precise seafloor mapping methods, precise seabed positioning system with a resolution of a few centimeters, new sensing system of thickness of cobalt-rich crust, etc. Finally, he examples using these technologies that the AUVs are practicable and variable tools for deep sea exploration. And he's also doing the big contribution to survey the results, damages from the earthquake and the tsunami of last year. So, Professor Ura, could you start?
Thank you very much, Kumagai-san. It's my great pleasure to talk about my research work. And I am an engineer, and I have been constructing many autonomous underwater vehicles in the 2 decades. Left-hand side, you can see our big cruising type AUV, which was constructed 2003, about 9 years ago. This is a cruising type AUV, like a torpedo. And right-hand side, it's an hovering type AUV named Tuna-Sand. And the vehicle can go up to 1,500 meters and take pictures of the seafloor like this way. And right-hand side is a playback of the behavior of the R2D4 when it was deployed in underwater volcano named Myojin-sho caldera. And the diameter of this caldera is about 9 kilometers. It's a very big one. And the right-hand side, this video was taken by Tuna-Sand. The depth is about 200 meters, and there is a shallow water hydrothermal vents. And 200 Celsius hot water is coming from the hole of the chimney like this way. So these are some these are images what the vehicles are doing in underwater. So that these pictures are the vehicles we have constructed in these 2 decades, and I have constructed more than 15 or 20 AUVs so far, and the configurations are very different vehicle by vehicle. And you can see this picture. This is a Tantan, which was designed for survey of Lake Biwa. And this was constructed in 2000, and this is the first AUV in the world specialized for lake survey. And I am the father of Tantan. Okay? And Michio Kumagai is the mother. He is a male, but he is the mother. And he has been taking care of the Tantan for 12 years. But I'm living in Tokyo, and I constructed many sons and daughters. Okay? And the other way. So I would like to briefly talk about the underwater platforms which can help you to survey underwater world. In autonomous underwater vehicles which are applicable in these decades, and Trident 1 is one of the examples we have constructed about 10 years ago. And remotely operated vehicle, JSON, this is an Uzuho remotely operated vehicle. And it is very active. And Camera-Roboj, it is usually called low-cost ROV. And this is a picture of RTB-100 constructed in Japan. And the manned submersible is also very active. This picture shows Jiaolong of China, which succeeded in going 7,000 meters last month. And it's a very successful dive. And so that I wrote some Chinese letter here. This is not Japanese, this is Chinese. Suisha Chichiren. It means an underwater robot in Japanese. This is Japanese, this is Chinese. I don't know you can distinguish Chinese and Japanese, but anyway, Jiaolong, I'm not sure you use such kind of deep submersibles, but there are 4 or 5 underwater human-occupied vehicles in the world, and the dive last month was very successful. But that's a human-occupied vehicle. We are not interested in human-occupied vehicle, but and I would like to show you how our autonomous underwater vehicle moves in the ocean. And this is a pool test of Trident 1 taken about 10 years ago in Jamstek pool. And this is a fully autonomous vehicle, so no teleoperation, okay? And the vehicle approaching to the cylinder, which is set on the pool floor and turns around the pile, keeping 1 meter distance from the surface and also keeping normal direction to the surface. So it is an example of survey of hydrothermal chimney in deep sea. The vehicle turns around once and takes pictures of the surface of the chimney like this way. And the vehicle turns 2 times around the pile and then turns to backward and found the second pile and continues survey of the surface of the second pile. So you know that this kind of autonomous behavior should be done in underwater. So that's our research topics. So I would like to introduce some recent results of the operation of Tuna-Sand. The Tuna-Sand was constructed in 2007 as the successor of the Trident 1. And the vehicle can dive to 1,500 meters and can take many pictures of the seafloor. And the vehicle went to the gas-hydrate fields in 2010, July, from 14th to 22nd. And this is the picture of gas-hydrate field in Toyama Bay. You can see white materials on the surface. This is methane hydrate. And there are very large volume of methane hydrate exposed in Toyama Bay. The depth is about 1,000 meters. So we did a joint research program with Professor Ryo Matsumoto. He is a gas hydrate scientist. And this is a schematic diagram of how gas hydrate fields can be generated. Methane comes from deeper part of seafloor and comes up, and the temperature becomes cold. And depth is about 1,000 meters, and the temperature is almost 0 Celsius. So that the gas becomes hydrate like this way, and some parts of gas comes out from this surface of the seafloor like this way. So there is a big volume of gas hydrate. And based on this methane, there are methane bacteria like this way, based on chemosynthesis. Okay? And also, there are many snow crabs who are enjoying lives at the top of food chain. And snow crab eat bacteria and some biotas based on chemosynthesis. Okay? So we operate the vehicle from Natsushima jumpstick ship like this way. And at the top of the vehicle, there is a steel camera and a strobe on the bottom. And there is a profiling sonar. And the vehicle should take pictures and should go very near to the bottom, so that the collision avoidance maneuvering is very important. Otherwise, the vehicle will be captured by the seafloor. So that the vehicle has a special sensing system. At the top, there is a laser system, and the lasers projected to the forward direction. And here is a video camera, and the vehicle watches the reflected line of the sheet laser, so that when the vehicle finds something, the vehicle should escape such kind of obstacle. So that kind of intelligence system is very important to operate a vehicle safely in hostile underwater world. The location is here. We are at Otsu, and the Joetsu city is here. And this is the gas-hydrate fields. This is Sado Island, and the Toyama Bay is here. And this is a bathymetry map measured by the surface ship. Depth is about 1,000 meters. And here is Joetsu Knoll, and southern part there is Umitaka Spur. And let's close up this area. And this is a bathymetry map. And so you can see some small mountains and small pockmarks. We call this one, southern one is Matsumoto Seamount, and north one is Hiromatsu Seamount. And let's close up so you can see there are many dots. This is the location of the remotely operated vehicle, which were operated by Professor Ryo Matsumoto. And so they are very interested in this one. And so in order to operate our Tuna-Sand, the bathymetry map is not so good, because the depth is 1,000 meters, and from the surface, the vehicle the surface ship measure the bathymetry based on a multi-beam echo sounder. So that the resolution is not so good, because range is 1,000 meters. So at first we operated this kind of cruising type AUV just about 100 meters above the surface, seafloor, so that we can get a very precise bathymetry map. And then we determine the destination of the operation of the Tuna-Sand vehicle. And this map is captured by cruising type AV. So you can see very detailed configuration of the seafloor. This range is 100 meters. So here is a very small pockmark, and some big pockmarks there are. So we operated the Tuna-Sand in this area because Professor Matsumoto are very interested in this area. So, and this is the results of its measurement of the seafloor by Tuna-Sand. So this is a contact curve of the seafloor. It is written in every 25 centimeters, so that we can see, let's say, a round shape, pockmark, and detailed configuration of the seafloor. And so this is a three-dimensional view of the seafloor. And you can see blue lines. This indicates the trajectory of the Tuna-Sand AUV. And when the vehicle moves in this area, the vehicle took about 600 pictures of the surface. This is the mosaic of the 600 pictures mosaicing. You can see a pockmark here, and also you can see many red dots. Okay, this size is 40 meters, and this size is about 20 meters. Red dots indicate snow crab, and white dots are sponges. And you can see a pockmark here. Pockmark is about 100 meters, and depth is about 5 meters. And in this picture, there are 400 big-sized snow crabs and 2,925 small crabs. Can you count from this one? And I would like close up these pictures, okay? Zoom up, double size, like this way. Finally, we can see what kind of food he is eating. So this kind of picture is very, very important to know what they are doing in wide area. Only one picture we can see very small area, but by making this kind of mosaic, we can know the wide area's ecosystem. That's very important. Based on autonomous underwater vehicle, we can take this kind of picture. That's the advantage of new technology. Okay, I would like to show that this kind of technology can be done based on the sophisticated software system. And this is a pool test of Tridog-1, which was carried out about 4 years ago. This is depth is about 5 meters, but there are some obstacles. So the Tridog-1 is keeping 2 meters above the seafloor, measuring the configuration of the seafloor by laser system. And based on this kind of fundamental research work, we can deploy a vehicle safely without no anxiety of trouble. This is the second track line the vehicle follows. And I would like to show how the vehicle did the diving. This line indicates the seafloor measured by the vehicle itself. The vehicle keep 2.2 meters altitude from the seafloor in order to take good pictures. Because stability is a little bit high, so the vehicle cannot go much more upward, and so that the 2.2 meters is a suitable altitude from the seafloor. The vehicle went like this way, and when the vehicle came here, the vehicle recognized that there is a high wall right-hand side. So then the vehicle went a little bit upward. And when he came here, he recognized that the wall is not so difficult. So that the vehicle went back to the bottom to keep to 2.2 meters altitude. And finally, the vehicle came to the Pop-Max walk, a very steep wall, and he decided that he should go up quickly, 1 meter or 2 meters above the cliff. So this is the way. So I would like to, and based on this kind of cruising was carried out perfectly in autonomous mode. So we took about 12 mosaic pictures in 6 days. So this is another example of the mosaic picture of the seafloor. And here, and the population is not so much here. And so big size snow crab is about 180, and small size 792 in 800 square meters. So here is also a big pockmark. And now, in the same way, I would like to close up, little by little. You can see here is a very big snow crab. The price, market price, this one is about $100 US. Okay, so and there are many small and big size snow crabs like this way. Here is a fish. And close up. And this is the original image. And you can see something strange here. Okay? How many legs this crab has? Only 4. This is okay, normal. This has only 1, 2, 3, 4. Why this kind of special? Why it occurs? Because gas hydrofields, in gas hydrofields, methane comes constantly, but sometimes it stops. So that when methane does not come, methane bacteria cannot survive. So that there is no food sometimes. And snow crab does not have anything to eat. But next door, there is a neighbor. Oh, let's eat. And after some times, bubbles of methane comes again, so they feel comfortable. That's the ecosystem of deep sea snow crab colony. So that's this kind of picture shows such kind of special unknown feature of underwater world. Before taking this picture, researchers had not known this kind of situation. So that based on new technology and based on new platform, we can find new special feature of underwater ecosystem. Okay. So that I would like to show you the three-dimensional image of hydrothermal vents at Kagoshima Bay captured by the same AUV Tuna-Sand. This is an hydrothermal vents. And in order to measure the configuration of the you can see the green laser line here, and we can scan the sheet laser like this way, and based on these complicated line, we can reconstruct the configuration of the seafloor like this way. And so this is a top view, and this is a side view of the vents. And the height is about 2.6 meters. We can measure this kind of detailed configuration using new platform that is autonomous underwater vehicle. So hovering type AUV is very good at taking pictures of seafloor for mosaicing. And so that the next step, what kind of technology we should develop? And the first one is construction of AUV troop, because AUV can move very slowly. So that in order to cover wide area, AUV troop is necessary. And the second step is the investigation into sub-bottom world without drilling a hole. And I would like to show up an example of measurement of thickness of cobalt-rich manganese crust. And this cobalt manganese crust is covered at the top of the sea mount, and the thickness is about 200 millimeters like this way. Excuse me. Like this way. We would like to measure the thickness by acoustically, but it is quite difficult because acoustic impedance of cobalt-rich crust is very similar to the rocks. So that when we project an acoustic wave from here to the surface, we can measure surface reflection. But this subsurface reflection is very weak, so it is quite difficult to measure the thickness of the cobalt-rich crust. But we developed a new acoustic system, which is here, and this is an amplifier system, and we put this system to the hyperdolphin of Jamstack, and we operate the system to the Takyo number 5 node. And this is the acoustic data. Blue dot indicate the surface, and red dot indicate the subsurface of the cobalt-rich crust. Based on this time delay, we can identify the thickness of the cobalt-rich crust in real time. And again, let's see again. This is a front view view of the seafloor cobalt-rich crust surface taken by the video camera fitted at the top of the vehicle. And this is also the down-looking video image. And based on this laser system, we can measure the detailed configuration of the seafloor. And so that Sorry. So, and this figure show the results of the measurement. This is the surface of the cobalt-rich crust, and you can see black dots here, and these indicate the thickness of the cobalt-rich crust. This is a close-up. You can see here, and this is the thickness of the cobalt-rich crust. And so, and based on that, so that's much. And this system is very successful. We would like to introduce to know how many cobalt-rich crust is on the top of the seamount. So I would like to say that with innovative platform and sensors, we can realize innovative observation. This one is a Chinese. Sorry. Oops. So that I would like, so now time is coming to over, but I would like to quickly show the recent results of operation of Camera-Roboj at Tohoku area. Last year, earthquake and tsunami attacked northern part of Japan, and this is the epicenter of March 11 earthquake. And we operated remotely operated vehicle, not autonomous underwater vehicle, because the area is very dangerous place. And this is the picture. Just tsunami is coming. Okay, you can see the ocean. After 30 minutes, the Shizugawa village is like this way. There are many floating materials on the surface of the bay, and this picture was taken from here and covered this area. And this figure shows the schematic diagram of the port. There are many facilities of aquaculture, and there is a small village. But in the seaweed, scallop, oyster, sea urchin, abalone are main products. But more than 10-meter elevation of the water comes here, like this way, and swept away. And the fisherman's nightmare is like this way. So there are many debris on the seafloor. There may be. So that reconstruction of aquaculture facility will be maybe very difficult, they supposed. But so they don't want to go to the ocean. So that it is necessary to know the actual feature of the seafloor after tsunami attack. So we operated remotely operated vehicle like this way, and we surveyed. But the results like this way. There is almost nothing, no debris on the seafloor where aquaculture facilities had been located. So that it has a very good data. So that's we operated a very old remotely operated vehicle. This was designed about 30 years ago. Anyway, these vehicles are very convenient in shallow water. We operated we deployed this vehicle 27 apart, and I would like to show a video image at the number 4 site. And you can see very clean sand on the seafloor. So fishermen's delighted. We can reconstruct quickly aquaculture facilities based on this kind of images. So that they were encouraged by this kind of video image. So I'd like to say that it is quite difficult to estimate what is happening underwater. So without observation platform, we cannot do anything. Our imagination is very poor. So let's operate remotely operated vehicles or autonomous underwater vehicles in the difficult deep sea. That's my basic idea. Anyway, it's very dangerous. So that's why we did not operate our autonomous underwater vehicle, because we know very little about the seafloor after the tsunami attack. So, but the remotely operated vehicle is very robust. so that we can operate the vehicle. So that's I would like to conclude that the underwater world is a very hostile battlefield out of our imagination. So that's when we can imagine the field precisely, the talented AUV can be operated by skillful engineers and supported by sufficient backups and can die successfully with small anxiety or without anxiety. So this is a very important word from Chinese military text written by Su Tzu, in Japanese, Sonshi. Know your enemy, know thyself, and you shall not fear 100 battles. Thank you very much.
Thank you very much, Dad. Maybe you have the question? Do you have the question? Comments or something? Time? Okay.
Time.
Thank you very much indeed.
Even over.